Today's lesson is solving systems of linear equations by substitution. Our learning goal: I will write and solve systems of linear equations by substitution, and I will solve real life problems. So today's lesson is just another method of equations. Yesterday you talked about graphing. Today we're going to talk about when you don't want to graph, or when the situation's just not very conducive to graphing. So first we need to start with a system. So y equals 3x minus 4 will be one of my equations. My other equation will be 5x minus 2y equals 10. So this right here is a really good example of when you're going to want to use substitution, because one of my equations is solved for y already. So this is y in terms of x. Another good time to use substitution something, so you have x solved in terms of y. And you'll see why this is in just a second. So what I want to do here, because I know that y equals 3x minus 4, I'm actually going to substitute that in to my other equation for the y variable. So what I'll do is I'll write the first part the same, 5x, and this is where I'm going to substitute the 3x minus 4 in for y. And that equals 10. So that's where my substitution is used. Up until this point, you've done a lot of substitution, but it's usually been just a number that you're substituting. Now we're substituting this entire expression, 3x minus 4, in for y. Notice that I put it in parentheses. I did that to make sure that everything gets multiplied by this 2. So whenever you make a substitution of an expression, you're going to want to substitute in parentheses. So now I'm going to go through. I need to solve this, basically. I have only x's in my equation, so it should be pretty straightforward to solve. I am going to want to change this to adding a negative 2, just to make sure that I distribute that negative properly, though. So this will be 5x plus negative 2 times 3x is negative 6x. Minus negative 2 times 4 is negative 8, because I'm subtracting a negative 8. That's the same as just adding 8. So that's what I get after I distribute. Okay, sorry, we had a little error in the recording. So I distributed and got this 5 plus negative 6x plus 8 equals 10. Then I combined 5x and negative 6x to get negative x. Then I subtract 8 from each side and I get negative x equals 2. But I don't want to know what the opposite of x is. If the opposite of x is 2, then positive x will be negative 2. Now you might be tempted to stop here, but this is actually only halfway. I need to take this negative 2 and I need to substitute it in either for this x up here or this x over here. So what I'll do, because I still need to know what y is, so I'll do y equals 3 times negative 2 minus 4. Y equals negative 6 minus 4, which is negative 10. So that tells me my solution for this system is negative 2, negative 10. Or the point, negative 2, negative 10, is the only thing that will work in both equations. And I can check this. I can check my math here and see that, yes, y is negative 10 if x is negative 2. I can also substitute these points into my second equation and do 5 times negative 2 minus 2 times negative 10 and see if that equals 10, just to make sure I did my math correctly. Negative 10 minus negative 20, I want to know, does that equal 10? This is negative 10 plus 20, so I do get 10 equals 10, and that's how I know that this is going to be the correct point. So if I were to graph this, these two lines would intersect at the point negative 2, negative 10. And that's basically the whole idea behind substitution. Another situation where I'm going to want to use substitution to solve would be a case like this. Y equals 5x. Things both equal y, then what that tells me is that they must be equal to each other. So basically I'm taking this 2x minus 3 and I'm substituting it in for that y. When I do that, I get 2x plus 3 equals 5x. And again, now I'm down to one equation. Solve it. I'm going to do that by subtracting 2x from each side. And I'll get 3 equals 3x. Divide each side by 3, and I get 1 equals x. But remember, I'm not done yet. I need to substitute this back into either one of these equations. So y equals 2 times 1 plus 3, which would be y equals 2 plus 3, or y equals 5. So my solution is 1, 5. Let's check it in this equation. If I put in 1 for x, 5 times 1 is 5, which is what y is, so 5 equals 5. So this one is a very, very obvious situation where I'm going to want to use substitution to solve. Now, what I would like you to do is try it on your own. So, try this. It looks just a tiny bit different, but you use the exact same method. X equals 5y plus 3, and 2x plus 4y equals negative 1. So go ahead and try that one on your own. When you're done, you can play the video again, and we will check your answer. Okay, so like I said, this situation, it's set up just a little bit differently, because instead of having y equals, we have x equals, but I'm going to use the same method. I'm going to take this 5y plus 3, and I'm going to put it in for that x right there. So this is going to become 2 times my x, which is the same as 5y plus 3, plus 4y equals negative 1. And then I'm going to go forth from there. First I have to distribute. 2 times 5y is 10y. 2 times 3 is 6. I'm still adding 4y. That equals negative 1. Now you see I only have one variable left, so I can solve for that. Let's first combine 10y and 4y. I get 14y plus 6 equals negative 1. Subtract 6 from each side. 14y equals negative 7. Divide by 14, and I get y equals negative 1/2. And then from there, now that I know what y equals, I'm going to substitute that back in up here. I'll substitute into the first one because it's just set up a little bit nicer. It's all ready to go. So x equals 5 times negative 1/2. So that's x equals negative, or negative 5/2 plus 6/2. I just wrote this with a common denominator. Negative 5 plus 6 is a positive 1/2. So x equals 1/2, y equals negative 1/2 would be my solution, and this is how I'm going to write. Okay, this final problem has us doing a word problem. So a weightlifter uses a total of 12 plates to add 260 pounds to a bar. So if you imagine, a weightlifter, they have their bar and then they put those plates on the end to make it heavier. He uses 45-pound plates and 10-pound plates. We want to write and solve a system to find the number of each used. So we know that we have two different types of plates. One type is 45-pound, one type is 10-pound. We know that altogether he used 12 plates, and the weight is 260 pounds. So let's let x equal the 45-pound plates, and let's let y equal the 10-pound plates. Or that's the number of 45. So how many 45-pound plates is x? How many 10-pound plates is y? We know that the total number of plates used is x plus y, that's all of the plates, and that's 12. He used 12 plates altogether, or she, I don't know, I'm saying he. And then we know that the amount of weight adds up to 260 pounds. And that weight is going to be 45 times the number of 45-pound plates plus 10 times the number of 10-pound plates. That's how much weight from 45-pound plates. That's how much weight he gets from the 10-pound plates. Altogether, he gets 260 pounds. We're going to use substitution to solve this. And you'll notice that neither of these is set up as either x equals or y equals. So our first step is actually going to be to rewrite one of these equations. Let's solve this top one for y. That's going to be really easy because it doesn't have a coefficient, and it just makes, the more simple the equation is, the easier it is to solve for one of the variables. So to do that, I'm just going to subtract x from each side, and I get y equals 12 minus x. Now I'm going to take this and put it in for that y right there. So the equation that I'm going to use to solve will be 45x plus 10 times, remember I'm substituting 12 minus x in for y, and that equals 260. So I made my substitution, and now I want to solve. So 45x plus 10 times 12 is 120, minus 10x equals 260. So if I do 45x minus 10x, I have 35x plus 120 equals 260. Subtract 120 from each side. I get 35x equals 140. Divide each side by 35, and I get x equals 4. So what that tells me is 4 45-pound plates were used. And then if I go back up to this original equation, the x plus y, 4 plus y has to equal 12. So it's pretty obvious from this that if I use 4 45-pound plates, there need to be 8 10-pound plates used. And to make sure that makes sense, well, 4 and 8 make 12, so that's 12 plates total. And then the 4 45-pound plates are going to weigh, let's see, for 180 pounds, plus another 80 pounds from 8 10-pound plates is going to be 260 pounds. So my answer, what I would write down is I would say 4 45-pound plates and 8 10-pound plates. So because this is a story problem with a context, my answer is going to be in context. Of course, I could have used y for 45-pound plates and x for 10-pound plates, so that's why I need to, at the very beginning, identify my variables, and then at the end, I answer it based on the question. I don't just say 4 and 8. So that's all there is to it.